The infinite clockwork. We are dust, watching the fire. The universe is vast beyond imagination. But even in that endless sprawl of stars and silence, there is one place we call home, a small spinning system, anchored to a star halfway out in one spiral arm of a mid-sized galaxy. The solar system, a name both poetic and precise. Solar, from sol, the Latin name of our Sunday. System, because it is a machine, ordered, predictable, a dance of gravity and time. There is nothing chaotic about this place. Even its violence is rhythmic. Meteors fall, planets pull, orbits wobble, but everything answers to gravity, like gears in an invisible clock. 9 billion kilometers wide and still growing, our system holds more than just planets. There are belts of rock, clouds of ice, forgotten dwarf worlds, and countless fragments of beginnings. Asteroids older than bones, comets trailing frozen secrets, each a page in a story older than Earth itself. And at the center, the sun, a nuclear heart pumping light through the veins of space. Everything in this system is connected to that heart. Planets don't just orbit, they are bound, chained by the sun's mass, whipped around by invisible threads of force. Without it, there would be no motion, no light, no time. This is not just astronomy. It is architecture. It is symphony. It is myth. Mercury, the scorched messenger, forever racing. Venus, shrouded in poison and beauty. Earth, the blue miracle. Mars, the red wound. Jupiter, the storm king. Saturn, the ringed sentinel. Uranus and Neptune, cold giants in a distant dream. Pluto, exiled but not forgotten. Each world spins its own tale, and in their company move moons, dozens of them, some dead, some hiding oceans, some echoing with mysteries we've only begun to ask. Out beyond Pluto, a frost-bitten frontier of ancient debris, the Kuiper Belt, and farther still, a halo of ghostly ice. The Oort cloud, the edge of our system, the waiting dark. But before we wander far, we begin with the sun. Because the solar system isn't just a collection of rocks and gas and fire, it's a family, and the sun is the parent. Fierce, life-giving, dangerous, divine. It formed from the collapse of a giant cloud of gas and dust, some 4.6 billion years ago. A slow, burning birth. Its gravity pulled everything around it into order. From that collapse came the planets. From that chaos, us. And even now, after all these eons, the sun still rules. To understand the solar system, we must first understand its heart. The sun does not rise. We do. We spin toward its light and call that morning. It is not just a glowing ball in the sky, it is a star, ordinary in size, extraordinary in significance. A sphere of plasma, a fusion engine burning so furiously it bends time, births shadow, and dictates life. At its core, chaos. 15 million degrees of pressure and heat. Hydrogen atoms collide with such force they become something new, helium. That transformation, that fusion, is what lights our sky. Each second, the sun converts 600 million tons of hydrogen into energy. Some of that energy will reach your face in about 8 minutes, making your skin warm and your plants grow. The light you feel is ancient. It began its journey at the core, bounced through layers of atomic crowding, the radiative zone, where photons take thousands of years to claw their way outward, zigzagging like prisoners in a maze. Above that, the convective zone, where heat churns in vast columns, like molten honey rising and falling. These convective currents create solar granules, cellular patterns across the sun's surface, each one the size of Texas and lasting only minutes before boiling into nothing. Then comes the photosphere, the surface we see, not solid, not fixed, but the visible skin of a fluid star, yellow-white, pockmarked with sunspots, dark, cooler regions shaped by magnetic tantrums, and higher still, paradoxically hotter, the chromosphere and the corona. the sun's outer atmosphere, stretching millions of kilometers into space. The corona is ghost-like, only visible during an eclipse, but hotter than the surface itself, a mystery that still stings at the edge of our understanding. This star is not silent. It sings literally. It vibrates, pulses. Its internal tremors, solar quakes, ripple through it like music. And from those ripples we've learned its inner structure, a form of stellar seismology, the heartbeat of a god. The sun also breathes. A solar wind flows constantly from its corona, a stream of charged particles that sweeps through the solar system. This wind sculpts planetary atmospheres, ignites auroras, and threatens astronauts. When it flares in coronal mass ejections, it can knock out satellites and stir geomagnetic storms on Earth. Even now, it rages. Yet it's stable. For a star, that is, middle-aged in stellar terms. About halfway through its life, 5 billion years behind it. 5 billion to go. One day, it will change, swell, cool, swallow Mercury and Venus, possibly Earth. It will become a red giant, then collapse into a white dwarf, a dense, glowing ember in the vast dark. But for now, it watches over us. A reminder, we live beside a bomb that never stops exploding, and we only exist because it does. Touching the fire. The ancients worshipped the sun. Modern science does something even bolder. It dares to approach it. In 2018, we sent a machine to do what no human, no probe, no dream had done before: to touch the sun. The Parker Solar Probe was not just another satellite. It was a messenger wrapped in carbon, a dare launched into fire. It flew with purpose, to dive into the sun's corona, the blazing aura surrounding our star, and learn the secrets written in heat and wind. This mission was not just about data. It was about understanding the very force that makes life possible, and sometimes threatens it. But how do you approach something that can vaporize steel? NASA engineered the answer: a heat shield unlike anything ever made. A carbon composite plate, 11.43 centimeters thick, facing the sun at 1,400 degrees Celsius, while keeping the instruments behind it a cool room temperature. That shield is its armor, its secret, its survival. Parker is small, no larger than a compact car, but its journey is vast. To reach the sun, it had to slow down, a cosmic irony, since falling inward is harder than escaping outward. It used Venus's gravity like a handbrake, looping around the planet multiple times, shedding speed, spiraling closer to the solar inferno. It flies faster than any human-made object in history, up to 700,000 kilometers per h. At that speed, it could circle Earth in 5 minutes. And yet, it takes months to complete one orbit, each pass carving deeper into the sun's atmosphere. What is it seeking? The same question that has haunted astrophysicists for decades. Why is the corona hotter than the surface? Why does the outer atmosphere of the sun, the corona, blaze at over 1,000,000 degrees Celsius, while the photosphere below lingers at a mere 5,500 degrees Celsius? Parker searches for the answer in the chaos. Magnetic reconnection, Alven waves, particles dancing on field lines like sparks on electric strings. It measures the solar wind at its birth, catching particles before they cool and fade across interplanetary space. And when the sun spits in solar flares, in coronal mass ejections, Parker is there, riding the wave, feeling the punch, tasting the raw fury of a star. This probe carries the name of a living man, Eugene Parker, who first theorized the solar wind in the 1950s, a theory many once mocked. Now, his name flies among the flames, a tribute in orbit. The mission will last until 2025, maybe longer. Each orbit brings it closer, braver, more intimate, until in its final act, it will graze the sun itself, skimming just 6 million kilometers above the surface. Closer than Mercury, closer than madness. It will not return, but it will whisper what it learned across the void in radio pulses and magnetic sighs. A message from the edge of fire. The silent anvil. If the planets were cast in a celestial forge, Mercury is the hammer-scarred anvil left nearest the flame. Smallest of the 8, yet densest after Earth, Mercury is a paradox. It rushes around the sun faster than any planet, a sprinter locked in a gravitational chain. One orbit every 88 Earth days, 1 year in less than a season. And yet its rotation, its day, is slow and strange. One Mercurian day lasts 176 Earth days. Sunrise comes only twice in a Mercurian year. Time here folds in echoes. The surface is a scorched relic. Imagine the moon, but harder, darker, older. Craters that remember the birth of the solar system, plains of ancient lava. A landscape unchanging for billions of years, no wind, no rain, no breath. But below that battered crust, Mercury keeps secrets. Its iron core is vast, making up 85% of the planet's radius. For comparison, Earth's core is just 55%. Why is Mercury so metal-rich? Was it once larger, stripped of its mantle by a colossal collision? Or did the sun's gravity evaporate its outer layers in the system's turbulent youth? The core is not silent. Despite its size and Mercury's stillness, it generates a magnetic field, one of only 2 rocky planets to do so. But unlike Earth's strong global shield, Mercury's magnetosphere is weak, lopsided, tangled by the solar wind. The sun bombards it constantly. Temperatures swing from 430 degrees Celsius in daylight to negative 180 degrees Celsius at night, a planet of extremes, yet without an atmosphere thick enough to hold heat or life or clouds. And yet water ice lurks in its polar craters, hidden in eternal shadow. We did not know Mercury well until recently. Mariner 10 gave us our first close look in 1974, but only mapped 45% of the surface. Then came Messenger in 2011, a machine that orbited Mercury for 4 years, unveiling the rest of the map, probing gravity, scanning minerals, and crashing gently in 2015, its final whisper into the dust. Messenger showed us a shrinking world literally. Mercury is contracting as its core cools, creating long, high cliffs called scarps, hundreds of kilometers long. It is a planet wrinkling like an old apple. Now, a new mission approaches. Bepi Colombo, a joint effort by ESA and JAXA. Launched in 2018, it will arrive in Mercury's orbit in 2025. 2 orbiters, one for mapping, one for magnetism, will descend into the furnace to complete what Messenger began. We study Mercury, not because it is habitable, but because it is primordial. It remembers the violence, the raw metal, the forge. It is a fossil of formation close enough to feel the sun's wrath, silent enough to hold history in stone. A whisper of the beginning, a world of silence, steel, and sunlight. The drowned goddess. If Earth is the blue gem of the solar system, Venus is her twin drowned in golden poison. Same size, same mass, same rocky bones beneath. But oh, how differently they have aged. To look upon Venus is to see a planet wrapped in mystery and mourning. Her surface is hidden beneath thick, unbroken clouds, not white, but amber, suffused with sulfuric acid. A sky of fire and ash. The sun shines there but never touches her face. Above those clouds, Venus gleams brighter than any planet. The morning star, the evening star, the first to rise and the last to fade, known to every culture long before telescopes gave it form. But beneath that radiant veil lies a world of nightmares. The atmosphere is a crushing shroud, 92 times denser than Earth's. To stand on Venus would be to feel the weight of an ocean pressing against your chest. And the air? Not air. but carbon dioxide, thick and searing, with clouds laced in sulfur, raining acid that evaporates before it can reach the ground. And heat. Not just hot, the hottest planet in the solar system, hotter even than Mercury. Surface temperatures reach 465 degrees Celsius, enough to melt lead. This is the wrath of a runaway greenhouse effect, unchecked and eternal. No water remains. If Venus once had oceans and signs suggest it did, they boiled away long ago, torn apart by solar radiation and never reclaimed. Her surface, revealed only through radar, is a land of plains and volcanoes. Not jagged, like Earth's young crust, but smooth, soft, as if poured and cooled a world resurfaced in lava. Volcanoes rise across her body, some larger than any on Earth. Is she still active? We do not know, but the silence may be deceptive. And then the winds. Above the clouds, winds scream around the planet at 360 kilometers per h, circling once every 4 Earth days, a phenomenon called superrotation. Below, all is still, like a storm that rages only in the heavens. We reached her early, but rarely survived. The Soviet Venera missions, bold, tragic, extraordinary, were the first to pierce her veil. Venera 7 in 1970 was the first to land on another planet. It lasted just 23 minutes. Others followed. Venera 9 sent back the first pictures. Venera 13 recorded the sound, a ghost's voice in static. The American Magellan probe in the 1990s used radar to map nearly the entire planet, revealing fractured highlands, meandering channels, and the massive, mysterious volcano Mont Mons. And yet Venus remains elusive. We have touched her briefly, through fire and steel. But to truly know her, we must return. There are whispers of missions rising again, Veritas, Divinciplus, envision each seeking to unlock her past, her geology, her soul. Did Venus once breathe like Earth? Did she harbor water, life, balance? What broke her? The morning star may yet hold answers to our future. For she is not just a warning. She is a mirror. And mirrors, even burning ones, reflect more than just light. Beneath the clouds, the forgotten land. Radar sees what eyes cannot. Through the dense, unyielding clouds of Venus, Earth's machines have reached with invisible hands, sending pulses of radio waves that bounce back with secrets carved in stone. What emerged from this invisible dance is a world both alien and hauntingly familiar. Venus's surface, though hidden from our eyes, is a vast mosaic of plains, ridges, fractures, and domes, shaped not by water or wind, but by molten rock and pressure from below. It is a volcanic planet, sculpted by fire. Much of her surface is smooth, too smooth, where Earth's continents are marked by billions of years of tectonic drama. Venus seems young, as if she had been resurfaced all at once in a planetary exhalation. A global catastrophe? A slow flood of lava across all the land? We don't know, but the clues lie in her fractured skin. There are pancake domes wide, flat volcanic formations, like rising dough halted mid-bake. Coronae great oval scars, dozens to hundreds of kilometers across, formed by upwellings of magma beneath the crust. Unlike Earth, Venus shows no sign of plate tectonics. Her crust does not shift or drift. Instead, she swells. She cracks. She collapses inward or tears apart, as if her skin is struggling to contain the heat within. And that heat is immense. Beneath the crust, the mantle boils. The absence of plate boundaries may trap that heat, creating vast pressure. Eventually, it must escape. Some scientists believe that Venus periodically remakes her entire surface a cleansing fire every few 100 million years. Could it happen again? Is it happening now? We have no seismometers on Venus. No rovers to listen for the murmurs of magma or the tremble of stone. But hints suggest she may still breathe. In 2023, researchers analyzing Magellan data from the 1990s found something strange. A volcanic vent had changed shape over 8 Earth months. Had we captured an eruption, or just shifting ash, melted rock reflowing in the heat? If Venus is still geologically active, she is not dead, only dormant. Or perhaps dreaming. No rivers carve valleys here. No rain wears down the stone. But lava channels, some over 1,000 kilometers long, stretch across the plains. Like frozen blood vessels of a wounded world. Some resemble rivers, winding and branching, but they flowed with fire. There are highlands too, Aphrodite Terra, Ishtar Terra, names drawn from goddesses, rising like continents from the plains. Mountains tower here, including Maxwell Montes, higher than Everest, coated in mysterious radar-bright material, perhaps metallic frost, or even pyrite, a golden frost in a place where nothing should freeze, where no man could breathe, where machines die quickly. And still, we dream of walking there. Robots have survived only minutes. But ideas are forming: floating drones, hovercraft, even clockwork landers designed to survive in that infernal pressure. A lander that doesn't rely on electronics, but gears and springs. A mechanical heartbeat in a mechanical hell. To map Venus is to learn a new language, one written not in rivers and deltas, but in calderas and collapse, in the stillness of a world where motion hides beneath the skin. Venus has no seasons, no moon, no ocean. She rotates backward, slowly, a day longer than her year. Time on Venus is not measured by the sun, but by the flow of stone. Next, we look deeper, into her past and her possible future. Did Venus once know oceans and calm skies? And can her story warn us of our own path? The lost oceans of Venus. Once, perhaps, Venus had oceans. That's not poetry, it's a serious, unsettling hypothesis. Long ago, billions of years in the past, before the planet wrapped itself in sulfur and wrath, it may have had liquid water flowing across its surface, oceans, lakes, rain, clouds like ours. An Earth twin not just in size, but in promise. What happened? The clues are faint, scattered like ash across time. Venus rotates slowly. One day is longer than its year, but models suggest that such a spin could, under the right conditions, allow for clouds to form on the day side, reflecting sunlight and cooling the planet. But that's not what Venus chose. Or rather, that's not what happened. The leading theory is runaway greenhouse effect. As the sun grew brighter over time, Venus's surface warmed. Oceans, if they existed, began to evaporate. Water vapor, a powerful greenhouse gas, trapped more heat, accelerating the process. More evaporation, more heat, a spiral into hell. Eventually, the water boiled away, rising into the upper atmosphere where solar radiation broke the molecules apart. Hydrogen escaped into space, oxygen reacted with rocks, and the seas vanished. Now, Venus is a dry furnace. Her skies hold traces of water vapor, barely measurable. Her surface is a warning, written in stone and fire. And yet, she is not dead to us. She pulls us in, year after year, mission after mission. We sent Venera, Soviet landers that crashed, burned, and against all odds transmitted images from the surface. Yellow rocks, dim light, flattened machines. Magellan came next, not to land, but to sea. Orbiting from above, it mapped 98% of the surface using radar. A blind cartographer painting a molten land. Then silence for a time. But now, the silence breaks again. Veritas, NASA, and Envision, ESA, two ambitious missions set for launch later this decade. They will orbit, scan, probe. They aim to answer the haunting question: did Venus truly once have oceans? Is it volcanically alive? How did it become the world we see now? And could the same fate await Earth? Dave Inciplis, another NASA mission, plans to plunge through the atmosphere, a modern descendant of Venera, capturing data as it falls like a fiery snowflake into the crushing depths. And there are dreams beyond that. Floating cities in the upper atmosphere, where pressure and temperature are Earth-like. A strange twist. The most habitable place on Venus is above the surface. Futurists imagine airships drifting at 50 kilometers altitude, harvesting carbon dioxide, solar energy, data. Cities in the clouds, not metaphor, but proposal. And let's not forget the mystery of phosphine. In 2020, scientists announced they had found spectral traces of this molecule in Venus's upper atmosphere. Phosphine is rare, and on Earth, primarily produced by life microbes, decay, or industrial processes. Could there be something alive in the clouds of Venus? Skepticism followed. Data was reanalyzed. Debates flared. The truth remains elusive, but the question lingers. Venus is not just a dead world. She is a story half told. A mirror once clear, now cracked. A planet that teaches us not just about geology and atmospheres, but about fragility, about how quickly a paradise can be lost. Next, we return home to the third planet, to a blue world still holding oceans, still breathing. Earth. From space, Earth is poetry. A swirl of blue, white, green, and ochre, a breathing jewel adrift in a silent, dark sea. Unlike the scorched Venus or barren Mars, Earth moves. It pulses with winds, tides, lightning. It breathes through seasons, sighs with storms, and cradles life in countless forms. But beneath the clouds and oceans lies a truth stranger than the skies. Earth is alive not just biologically, but geologically. A restless, shape-shifting sphere of fire and stone. Its surface, that comforting ground beneath our feet, is not fixed. It drifts slowly, irresistibly, like ice flows on a molten sea. This is plate tectonics, Earth's great dance. The crust is broken into vast plates, massive rafts of rock floating atop the asthenosphere, a hot, viscous layer within the mantle. These plates collide, grind, slide, and split. Mountains rise, oceans open, continents migrate. The Himalayas? Born from a collision with Asia. The Atlantic? A widening scar between ancient lands. The Ring of Fire? A volatile seam stitched with volcanoes and quakes. Earth reshapes itself. It is not a sculpture. It is a sculptor. Beneath the crust, heat flows upward, remnants of planetary formation, radioactive decay, and the lingering ember of Earth's core. The core itself is a wonder. A solid inner sphere of iron and nickel, spinning within a liquid outer shell, generating a magnetic field that shields the planet from solar fury. A planetary heart with a magnetic pulse, the geomagnetic field that protects our atmosphere and our DNA. Without it, life would struggle to survive. Radiation would strip away what the sun gives. And so, in Earth, we find a balance of violence and protection. It is this delicate paradox that makes life not just possible but resilient. And life has shaped Earth as much as Earth shaped life. Consider this. For 2 billion years, cyanobacteria filled the skies with oxygen, changing the planet's atmosphere and killing most life at the time. A great oxidation event, both apocalypse and genesis. Mountains weathered into dust-fed rivers. Rivers carve canyons. Volcanoes fertilize soil. Microbes alter minerals. Trees hold soil in place. Worms churn it. Whales fertilize oceans. The biosphere, the thin film of life coating Earth's surface, is not a passive layer. It's an active force, cycling carbon, nitrogen, phosphorus, energy. A planetary system within a planetary system. Life isn't just on Earth. Life is part of Earth, a component as critical as mantle or core. Our planet is a feedback loop of rock, air, water, and life. A breathing, bleeding, burning mosaic of systems nested within systems. And the more we study it, the more we realize how fragile and how rare this kind of balance is. Venus lost hers. Mars never quite had one. Earth somehow held the line. For now, the silent companion, the moon. It hangs above us like a memory etched into the sky, silent, pale, unwavering. The moon, a companion older than memory itself, carved from a cosmic collision some 4.5 billion years ago, when a Mars-sized wanderer struck the newborn Earth with the force of creation and destruction fused. From that fiery impact, debris rose, a halo of molten rock and ash, spinning and cooling into a satellite that would never stray. Our moon. Its face is scarred, cratered, ancient. It wears its wounds like medals, evidence of the wild bombardments that once shook the early solar system. Basalt plains, or maria, stretch across its near side. Silent seas formed from lava flows, long cooled. And yet it is not a dead thing. Not entirely. Though tectonically still, it pulls at Earth's oceans with invisible fingers, guiding tides, whispering in rhythms only water and time understand. It stabilizes our axis, calms the wobble that might have undone climates and seasons. Without the moon, Earth's song would be less steady, its cradle of life more fragile. Humans, too, have long felt its pull. We howled at it, measured months by its phases, linked it to gods, madness, longing. Then we went there. In 1969, humans walked upon another world for the first time. Boot prints in dust untouched for billions of years. The Apollo missions revealed what poetry had guessed, that the moon was both a mirror and a relic. It carries clues to Earth's own formation, records untouched by erosion or atmosphere. A time capsule from the solar system's youth, quietly orbiting, waiting to be read again. Now we return slowly, purposefully. Artemis is coming. Not just a flag and a footprint, but a foothold. The moon as launchpad, as partner, a stepping stone to Mars, a laboratory, a sentinel, a beginning once more. Above us, it still glows, cold, familiar, forever near, yet always just beyond reach. Our first frontier, a red whisper in the sky, a god of war, a cold ancient world that once may have dreamed in blue. Mars, fourth from the sun, but first in our imaginations. A planet so close, so familiar, and yet so alien. Its surface glows rust red with iron oxide, a scarlet desert stretching for miles upon miles. Beneath the ochre dust lie stories of cataclysm, of water, of potential. Geology is the language Mars speaks. And oh, what a storyteller it is. There's Olympus Mons, the tallest volcano in the solar system, towering nearly 3 times the height of Everest. Its base is so wide, it curves with the planet's surface. Then there is Valles Marineris, a wound so deep and long it could stretch from New York to Los Angeles. A canyon system carved not by rivers, but by tectonic tension and collapse. Mars has no drifting continents, no plates in motion. But once, perhaps, its interior stirred more violently. Today, its core is cold, its magnetic shield long faded. The solar wind now scours its atmosphere, without resistance. Still, the evidence of water lingers. Frozen caps at its poles, seasonal flows of briny trickles, mineral veins etched into crater walls, and ancient riverbeds dry as bone, but unmistakable in their form. Billions of years ago, Mars may have had a thicker atmosphere, a climate mild and damp, a world of lakes, perhaps even seas. Could it have nurtured life? If life did spark there, was it microbial, hidden beneath the surface? Did it leave behind traces, fossils? Or has all evidence been lost to time, to dust? We've sent our eyes. Orbiters have mapped every hill and hollow, watching for seasonal changes, measuring atmospheric wisps and mineral fingerprints. And we've touched down, from Sojourner's cautious rolls in the 90s, to Spirit and Opportunity, who wandered far longer than anyone dreamed, to Curiosity, still crawling through Gale Crater, and now Perseverance, drilling and caching samples in Jezero, where a river once fed a lake, and deltas hold secrets in their clay. Each rover is a scout, a whisper in a land of echoes. Their tracks are the first signs of movement in ages. They search not just for water, but for the memory of life. Mars listens. It watches with frozen, dust-choked eyes, waiting for us to decipher its silence. And we listen back, hearts pounding, every signal from its surface, a heartbeat of the dream to come, to walk there, to breathe beneath its pink sky, to find out, finally, if we are alone. The journey to Mars began not with footsteps, but with signals, wings, and wheels, long before any human would dare dream of touching its cold soil. We sent scouts, machines of silicon and alloy, to test the silence, to taste the dust. It began humbly. In 1965, Mariner 4 became our first successful envoy. A few dozen grainy images, but enough to destroy an old myth. No canals, no cities, just craters and wind. Mariner 9 followed, the first to orbit another planet. And when it arrived in 1971, a global dust storm veiled the world. Mars revealed itself slowly, a drama of volcanoes, canyons, and mystery. Then came Viking, 2 landers, 2 orbiters. In 1976, the Vikings gave us our first clear view of the Martian surface rocks, red soil, and sky. And they asked the question directly, is there life? They tested the soil for metabolism. Some results sparked hope, but the consensus faded. No definitive proof. Still, the dream didn't die. In 1997, the rover Sojourner trundled off its ramp. Small, slow, but brave. It sniffed rocks and sent back wonder. Proof we could drive on Mars. Then the Golden Twins, Spirit and Opportunity. Meant to last 90 days, they lived for years. They crossed craters, climbed hills, and found the impossible. Signs of ancient water, minerals that only form in wet conditions. Opportunity fell silent in 2018, after a global storm smothered its panels in dust. Its last message was a whisper. My battery is low, and it's getting dark. We listened. We cried. Then Curiosity, the nuclear-powered geologist. Larger, smarter. It landed in 2012 with a sky crane descent, like science fiction come to life. It explored Gale Crater, finding clay, organics, and evidence of habitability. And now, Perseverance. Its mission, to prepare for human arrival. It landed in Jezero Crater, where a river once poured into a lake. Delta sediments hold secrets. If life ever lived, its fossils may sleep there still. Perseverance carries moxie, a machine that breathes, extracting oxygen from thin Martian air. And with it came a scout, Ingenuity, the first aircraft to fly on another world, tiny, buzzing like a dragonfly. It flits from stone to stone, not just proving flight, but mapping the way ahead. These rovers are our eyes, our hands, our whispers across the void. Each signal is a story. Each wheel track, a new line in our poem to the stars. They prepare the way, not just for knowledge, but for boots, for breath, for the moment a human voice says, "I am standing on Mars." Beneath the crimson sky and storms of rust, Mars hides a skeleton of stone, a record etched in basalt and ash, waiting to be read. Its face is deceptive. Endless plains, jagged cliffs, a silence that screams of stillness. But listen closely. This world once roared. Start with the north. The northern lowlands, smooth and sprawling, may once have been an ocean bed, billions of years ago. Perhaps a shallow sea lapped at its edges, nurturing chemistry, maybe even life. To the south, the southern highlands, ancient, cratered, a battered history book, older than any terrain on Earth. Here, each impact tells a story, each valley a whisper of flowing water. Cutting through the crust, Valles Marineris, the grandest canyon in the solar system, over 4,000 kilometers long, 10 kilometers deep. If Earth had a scar like this, it would stretch from New York to Los Angeles. It wasn't carved by rivers alone. Tectonics tore it open, a planet shifting beneath its skin, fracturing, collapsing, gasping. To the west, a behemoth sleeps. Olympus Mons, the largest volcano known to humanity, 3 times the height of Everest, wide enough to swallow France. A relic of a different Mars, a time of fire, magma, breath. But unlike Earth, with its restless plates, Mars's crust is still. So lava pooled in place, rising and rising, until the god of mountains was born. And there's more. Tharsis Bulge, a swollen region of ancient uplift, home to Olympus and its fiery kin. This bulge warped the entire planet, changing river flows, perhaps even its spin. Then the water. Yes, water. It ran once, in gullies and deltas, etched channels in the stone, left behind salts, clays, and hope. In places like Jezero Crater, a delta stands fossilized, proof that a river once slowed and spilled into a lake, dropping silt and secrets. There are signs of glaciers, too, hidden beneath dust, ice preserved in shadows and poles. Mars was wet, and then it wasn't. Something happened. Its magnetic field died, its atmosphere thinned, and the water vanished, fled, froze, escaped. Was it sudden or slow, like a candle guttering in the wind? We don't know, but we dig. We scan, we drill, we sample. Each rock core pulled by perseverance, each mineral studied by curiosity, brings us closer to the heartbeat that once was. Mars is not dead. It sleeps. And in its bones, a story still stirs. There's a question that refuses to die. Did life ever arise on Mars? Or worse, is it still there, watching us quietly? No answer has arrived, but the evidence? It whispers, it teases. 1,000 tiny hints wrapped in contradiction. Start small. Methane. Traces detected in the atmosphere. Seasonal, fluctuating. Not constant, not random. On Earth, methane often means life. Microbes digesting, cattle breathing. a planet alive with chemistry. On Mars, it could mean geology, rocks cracking, water reacting, or it could mean biology. Methanogens, simple, ancient organisms, might still dwell in Martian soil, hidden in ice, deep underground, safe from the sun's sterilizing glare. We've searched. Rovers like Curiosity and Perseverance sniff the air, taste the dust, scan for organics, and they've found them. Fragments, carbon-based molecules, the building blocks of life, not proof, but possibility. In Gale Crater, Curiosity drilled into ancient mudstone. The rock sang of sulfur, nitrogen, even complex organics, preserved for billions of years, as if waiting for an audience. Then there's Jezero Crater, where Perseverance roams. Once a lake, once fed by a river, now a fossilized delta. And deltas on Earth are teeming with life, with stories. The rover collects samples, stores them for a return mission. A dream decades in the making. Someday, they'll come back to Earth. And maybe, just maybe, we'll find microfossils locked in clay, silent witnesses to Martian history. But life needs more than water. It needs stability. It needs protection. Mars offers little of either now. Radiation batters its surface. UV light sterilizes. The air is thin, dry, cruel. Yet life finds a way. On Earth, microbes thrive in boiling vents, beneath Antarctic ice, inside salt crystals. So why not Mars? If life arose here, it might have sunk underground, retreating into warmth, into pockets of briny water, kept liquid by salts and pressure. Or maybe it died, snuffed out when the atmosphere faded, when the warmth fled, when Mars turned from blue to red. We don't know, and that not knowing burns. Because if life existed on Mars, even once, then we are not a cosmic accident. We are a pattern, a repetition, a verse in a universal song. And if life still exists on Mars, even microbial, then we are not alone. Even if our neighbors are silent, small, and older than memory. So we keep searching, with eyes, with wheels, with dreams, because sometimes the dust remembers. One day, they will walk there. Across regolith, the color of dried blood. Bootprints pressed into ancient dust. The first steps on a new world. That dream isn't new. It began long before Perseverance. Before Opportunity sang her last lullaby. It began with a simple idea. Mars is next. But Mars is not easy. Getting there is hard. Staying harder. Surviving? Heroic. Yet we plan. Governments, private firms, visionaries with deep pockets and wild eyes. NASA's Artemis program dreams of a lunar base, a stepping stone. SpaceX sketches starships, bold and sleek, meant to carry settlers across 55 million kilometers of void. Why? Why risk the journey, the isolation, the madness of distance? Because Mars is a mirror, a reminder of what Earth could become, of what we might build. Terraforming fantasies swirl in think tanks. Release CO2s from polar caps. Thicken the atmosphere. Warm the planet. Make it blue again. But the timeframes are titanic. Centuries. Millennia. So we think smaller. Modular habitats. Pressurized domes. Farms lit by artificial suns. Radiation shields carved into lava tubes. We'll need water, mined from permafrost or sucked from the air. We'll need oxygen cracked from ice or CO2s. We'll need food grown in hydroponic trays, recycled, rehydrated, reimagined. And we'll need people. Brave, restless, stubborn. Engineers, biologists, dreamers. People who look at a hostile desert planet and say, "Yes, I will live here." Robots pave the way. Prototypes test drilling rigs. Cargo modules practice landing. Simulated Martian colonies bloom on Earth in Utah deserts, Icelandic tundras. We build little Marses to prepare for the real one. And still danger stalks every plan. Dust storms that span continents. Power failures in cold darkness. Psychological strain in metal boxes light years from home. Mars is not a postcard. It's a crucible. But that's the point. Because going changes us. It always has. Crossing oceans, scaling mountains, launching skyward. Mars is the next mountain, the next impossible. And somewhere, out there, a child is watching stars through a frosty window, whispering, "Someday I'll go." And someday, they will. Before we ever knew what Mars was, we imagined it. A red dot wandering across the heavens, unpredictable, untamed. To the Babylonians, it was Nergal, god of war and plague. To the Greeks, Ares. To the Romans, Mars. Not just a planet, a myth. And that myth never left us. As telescopes sharpened and maps were sketched, we filled the gaps with fantasy. Canals etched by Martians. Civilizations fallen to time. Ruins just waiting to be uncovered by brave explorers. Mars became the canvas for our imagination. From H.G. Wells's War of the Worlds to Ray Bradbury's Martian Chronicles, to every red-sanded science fiction set, Mars has always whispered stories, just beyond reach. And maybe that's the most powerful thing about it. Not what Mars is, but what it makes us feel. A lonely world. Cold. Silent. But not empty. Never truly empty. It's rich with meaning. We see ourselves there. Our hopes. Our fears. Our reflection. Only redder, more fragile, more raw. And now science begins to catch up to myth. We know Mars had rivers, lakes, maybe even oceans. It had warmth, magnetism, an atmosphere thick enough to breathe if only for a while. We know organic molecules lurk in its rocks. We suspect underground water still flows, hidden and briny. We wonder if life once bloomed, simple and microbial, but still life. The search continues. With every rover trench and spectrometer scan, we press our ears to Mars's silence, listening for the echo of a second Genesis. Because if life started twice, here and there, then maybe, just maybe, life is not rare. That possibility ignites everything. It means we are not alone. It means the universe is not a void, but a garden. And so Mars is more than a planet. It is a question. Who else has stood beneath these skies? Who might come after us? It is our next story. Our proving ground. Our myth reborn through science. A red thread winding from ancient temples to future launch pads. From war god to home world. And somewhere in all that rust and silence, Mars waits, not just to be explored, but to be understood. Jupiter does not orbit the Sun. Not entirely. They orbit each other, spinning around a shared center of mass just above the Sun's surface. That's how massive Jupiter is. So heavy, so gravitationally dominant, it bends the rules. It's not just a planet. It's a system. Its atmosphere is a storm-racked wilderness, a vast envelope of hydrogen and helium, boiling, swirling, crackling with lightning. There are no surfaces here, no land to stand on, just layers of cloud, descending into metallic hydrogen, where pressure crushes atoms into a sea more alien than any ocean. And above it all, the Great Red Spot, a cyclone twice the size of Earth, roaring for at least 350 years, maybe thousands. Nobody knows why it formed. Nobody knows why it still rages. Around it, bands of white and ochre, storms nesting within storms, a living painting in motion. Jupiter humbles everything. It holds 70% of all planetary mass in the solar system. You could fit 1,300 Earths inside it. Its magnetic field stretches millions of kilometers, forming a radiation belt more intense than anything we've ever encountered. And yet, despite all this violence, Jupiter has a protective side. Its gravity acts like a cosmic vacuum cleaner, pulling in comets and asteroids that might otherwise strike Earth. Some scientists believe we wouldn't be here at all if Jupiter hadn't taken the hits for us. It is our guardian and our monster, our destroyer and our shield, a paradox wrapped in clouds. We've sent missions: Pioneer, Voyager, Galileo, and now Juno. Each brought new data, each raised new questions. Why does Jupiter emit more heat than it receives? What fuels its endless lightning? Is there a solid core beneath those crushing clouds, or just a gradual shift from gas to metal? And what about those faint, ghostly rings? Yes, Jupiter has them too. Not grand like Saturn's, but subtle arcs of dust cast off by its moons. Which brings us to Jupiter's greatest wonder yet. Not the planet itself, but the worlds that orbit it. More than 90 moons, and counting. Some frozen, some volcanic, some possibly habitable. Jupiter is not a world. It's a solar system within a solar system. And in the chapters ahead, we'll meet the four Titans first glimpsed by Galileo. Moons that may one day reshape our understanding of life in the universe. But for now, let's linger here, in the storm shadow of a planet so vast, so mythic, that even from Earth, you can look up and feel its pull. Jupiter doesn't have weather. It is weather, a planet-sized tempest, a living vortex of color and chaos, where storms tower higher than Everest, and winds howl at 600 kilometers per hour, all without a surface to slow them. But peel back the beauty, and the danger becomes clear. The bands, those iconic stripes, are more than decoration. They're jet streams, racing in opposite directions, wrapping the planet in speeding belts of gas. The lighter ones, zones, are regions of rising air, clouds made mostly of ammonia ice, pale, sunlit, windswept. The darker ones, belts, are sinking air, warmer, deeper, where pressure builds and lightning flickers like underwater fireflies. It's here, beneath the upper clouds, that we find the deep mysteries. Juno, the latest probe to brave this world, has revealed a planet more complex than we ever imagined. The Great Red Spot? It stretches 300 kilometers deep. That's not a storm. That's a pillar. The magnetic field? The strongest of any planet, 20,000 times stronger than Earth's. It traps particles in deadly belts and shoots radiation like invisible lightning. Its shape is strange, lumpy, asymmetric, not the neat bar magnet field we expected. Something is stirring deep inside, something metallic, And that leads us to Jupiter's core, or lack of one. The deeper you go, the stranger it gets. Hydrogen, under such immense pressure, becomes liquid metal, an ocean of electrons and protons, conductive, wild, churning out the massive magnetic field. At the heart, maybe a solid core, or maybe a diffuse mix, a slurry of rock and gas, blurred by time and gravity. And in all this violence, there's beauty too. Jupiter has auroras, brighter, larger, and more powerful than any on Earth. They shimmer around the poles, dancing to rhythms of charged particles, screaming through the magnetosphere. They are not gentle. They are not silent. These lights burn with energy, strong enough to kill a probe in days if it strays too close. And yet, Juno flies still, orbiting close, diving deep, taking readings, snapping images, risking it all to answer the questions we didn't even know to ask. Why does Jupiter spin so fast? Why is the magnetic field so warped? Why do its storms live for centuries? Every answer reveals another layer. Every layer, a secret. And somewhere beneath it all, something ancient, something primordial. Jupiter wasn't born. It condensed. A gravity-wrought titan, a failed star, still burning faintly. With the heat of its birth, it is not done teaching us. But to learn more, we must turn outward to the moons that orbit in its shadow. Europa Ocean beneath ice. Imagine a world so quiet you could hear the creak of its own shell. Europa drifts in Jupiter's grip, a moon wrapped in ice, smooth as glass, cracked like a frozen sea. But this is no dead world. Not anymore. Underneath that frozen crust, perhaps just 10 to 30 kilometers thick, lies an ocean. A real, global, salty ocean, tens of kilometers deep, kept warm by the constant kneading of Jupiter's gravity. This is not poetry. It's physics. Tidal flexing. As Europa orbits, its icy body stretches and relaxes again and again, like a heartbeat. The friction of this endless motion creates heat deep below. And where there's heat, there might be life. Scientists look at Europa and see Earth's deep-sea vents. They imagine hydrothermal plumes, rich in minerals, surrounded by alien microbes, thriving in the darkness. No sunlight, no photosynthesis, just chemistry. Life born from stone and water. Cracks on the surface called lineae crisscross the moon like scars. Some are filled with reddish salts, maybe from the ocean below. Others erupt geysers into space, spraying water vapor hundreds of kilometers high. We've seen them. Hubble caught the plumes. Galileo saw the cracks. And the upcoming Europa Clipper mission will go closer than ever, mapping the ice, tasting the spray, looking for signs of something stirring in the deep. Europa has no atmosphere to speak of, just a whisper of oxygen formed by radiation breaking down ice. But that same radiation also powers chemistry, creating oxidants that could fall back into the ocean and feed a whole biosphere. This moon, smaller than our own, may be one of the best places in the solar system to find life. It's not just speculation. It's hope, grounded in data, launched by curiosity. Europa is no longer just a moon. It's a world of possibilities, a sealed blue dream waiting to be opened. And it's not alone. Jupiter's other moons each tell their own story. some of fire, some of ice, all of them ancient. Ganymede, the magnetic moon. It doesn't scream for attention. No dazzling rings, no erupting plumes. Just presence, massive, silent, unshaken. Ganymede is the largest moon in the solar system, larger than Mercury, with its own magnetic field, its own voice in Jupiter's orchestra of worlds. Yes, you heard that right. A moon with a magnetic field. The only one. How? Inside Ganymede, beneath its icy crust, beneath the fractured rock, beneath the pressure of ancient time, there churns a liquid iron or iron sulfide core, a dynamo, spinning and alive. This field interacts with Jupiter's massive magnetosphere, creating auroras at its poles, glowing curtains of energy on a world with no sky. Its surface is a frozen history, dark regions, old and cratered, bright bands, grooved and fractured, where ice has stretched and split, like old leather under stress. It's a world shaped not just by impacts, but by tectonics, by forces from within, ripping and repairing the crust over eons. Beneath the surface, scientists believe there may be multiple layers of ocean, sandwiched between sheets of ice. A stacked sea, hundreds of kilometers deep. Some models say ice, ocean, ice, ocean again, then rock, like a cosmic tiramisu. No confirmed plumes here, no eruptions, but the clues: magnetism, surface features, gravity measurements. They whisper something hidden, ancient, vast. When Galileo flew past Ganymede, its instruments caught magnetic disturbances. When Hubble watched its auroras, they danced, tilted, moved by something beneath the ice. Water, maybe not like Europa's salty, active ocean, but still liquid, still potential. The JUICE mission Jupiter, Icy Moons Explorer, is on its way. It will orbit Ganymede, the first spacecraft to orbit any moon besides our own. It will map the surface in detail, probe the internal layers, search for signs of past or present oceans, and listen to the hum of magnetism, to the silence of secrets. Ganymede is not a world of drama. It is a world of depth, of slow-moving stories, of geology and magnetism, of frozen time. But don't mistake stillness for emptiness. Ganymede endures, and in its endurance, it remembers everything. Callisto, the ancient cratered world. Silence is deeper here, colder, older. Callisto is a relic, an artifact from the early solar system, preserved in ice and shadow. It is Jupiter's second largest moon, almost the size of Mercury, but unlike Ganymede or Europa, Callisto doesn't churn. It doesn't groan with shifting plates. It doesn't pulse with hidden oceans. It simply waits. Its face is scarred, not with time, but with the memory of impacts that have not faded. Craters overlap like echoes. No wind to erode, no lava to smooth, no tectonic breath to shift the scars. It is the most heavily cratered object. In the solar system, the surface is a palimpsest of violence. Valhalla, the massive multi-ringed impact basin, ripples out like a cosmic bruise, the result of an ancient collision, and still, it rests, unchanged. When Galileo passed by, it sent back a different kind of silence, a lack of magnetic interaction, no inner dynamo, no signs of geological activity. And yet, beneath the frost, beneath the dust, there might be more. Models suggest a subsurface ocean buried under 100 kilometers of ice. Briny, ancient. Still, not stirred by tides like Europa, not warmed by cores like Ganymede, but heated just enough by radioactive decay to maybe, just maybe, keep water in its liquid state. NASA's Juno mission flying past Callisto has offered new glimpses, subtle signals, hints of complexity beneath that calm, dead skin. But life? Unlikely. This is not a world of promise. Not in the way we dream. This is a tombstone of the early solar system, a record left untouched. And therein lies its value. Callisto tells us what the other moons can't. What it means to be still when everything else is changing. It is a control group, a constant in our search for oceans, for life, for drama. Callisto whispers, remember the others. Remember what was. Sometimes, to understand motion, you must first study stillness. Io, the volcanic inferno. There is no silence here, no stillness, no peace. Io is a moon in perpetual rage. It twists, it screams, it erupts. Every 40 hours, it is pulled by Jupiter, and by Europa, and by Ganymede, tugged in 3 directions at once, stretched like taffy. That tidal flexing heats its insides, not softly, but violently. The result? The most geologically active body in the entire solar system. Its surface is alive with volcanoes, lava lakes, fountains of sulfur, rising hundreds of kilometers into the thin orange air. From orbit, Io looks like a pizza or a burn. Yellow, red, white, black, stains of chemical fury. Where Callisto is a fossil, Io is a furnace. The volcano Loki Patera, named for the Norse god of mischief, brightens and dims like a celestial heartbeat. It may be a lava lake with a solidifying crust that sinks and reforms again and again. Other eruptions, Pele, Prometheus, burst upward with such force that they escape gravity and snow sulfur back across the moon. There's no rest here. No place stays the same for long. The surface is young, always being resurfaced, erased and rewritten by fire. Underneath, no ocean, no promise of life, just heat and pressure and change. It's not life-bearing, not in the way we define it, but it is alive. In the raw elemental sense, it reminds us that moons can be as varied as planets. Some with ice, some with oceans, some, like Io, with hearts of flame. And though we might not settle there, though no astronaut may ever tread its blistering plains, we still look at Io and marvel, because not every world has to harbor life, to be a story worth telling. Some are here to show us what energy can do when the universe refuses to hold back. Saturn, the ringed giant. It floats. That's the first thing. Saturn could drift in water if there were an ocean large enough to cradle a planet. It's a gas giant, like Jupiter, but more delicate, less dense, paler, wreathed in golden fog. And then there are the rings. They are impossible, thin as tissue, wide as moons, billions of icy fragments, tracing perfect orbits in an elegant, endless ballet. They shimmer, each ringlet, A, B, C, Cassini division, a chapter in a celestial symphony. not permanent, but fleeting, transient beauty, measured in millions of years. Scientists think the rings might be the shattered remains of a moon that came too close, or a collection of comets torn apart by Saturn's unrelenting gravity. But even broken things can be beautiful. Beneath the rings, the planet spins, a yellow and cream marble with winds faster than sound. There are storms the size of Earth, and a curious feature near the pole, a hexagon of cloud, stable and strange, turning endlessly like a sacred symbol etched in gas. And then there are the moons, dozens, each stranger than the last. Some, like Enceladus, are cold and bright, and spraying water into space. Others, like Titan, are worlds unto themselves. Saturn is more than its rings. But oh, those rings, you don't need to be a scientist to fall in love with them. You don't need to understand their origin to stand in awe. They remind us that the universe can be both ancient and elegant, that even giants can wear jewels. Enceladus beneath the ice, it glitters, white as bone, bright as a mirror, cold enough to crack steel. Enceladus, one of Saturn's many moons, is small, just 500 kilometers across. But it holds a secret that has changed everything. From the outside, it looks like a snowball, smooth, icebound, innocent. But in 2005, the Cassini spacecraft flew close and saw something unexpected. Plumes, water, spraying into space from fractures in the southern hemisphere, like steam from vents beneath an ancient sea. They call them tiger stripes. From these dark slashes shoot geysers of water vapor, ice particles, and most incredibly, organic molecules. Not just water, but salt, methane, ammonia, complex carbon compounds, the signs of a subsurface ocean. Hidden, liquid, warm. Warm? Yes, because inside Enceladus, beneath that thick shell of ice, something stirs. Gravity from Saturn pulls and kneads the core, generating heat, enough to melt the interior, enough to sustain a sea, maybe even a cradle for life. And that changed the game. We used to think life needed sunlight, that it sprang up in warm shallows under blue skies. But Enceladus whispers another story. Life might bloom in the dark, in the silence of an alien ocean, warmed only by tidal friction and ancient rock. Cassini flew through the plumes, tasted them, analyzed their chemistry, and found tantalizing signs, not life itself, but the building blocks. Enceladus is now high on every list of places we dream of returning to, not to take pictures, but to dive, to land, to drill, to send robotic swimmers into that unseen sea. Because if there is life there, even simple microbes, it means we are not alone. And Enceladus, the quiet moon, will have shouted the loudest truth in the history of science. Titan methane skies and alien seas. It rains on Titan, but not water. Methane. Golden droplets fall from hazy skies onto lakes and rivers made of hydrocarbons. This is Saturn's largest moon, bigger than Mercury, thicker atmosphere than Mars. And unlike any other place we've seen, Titan is a paradox. So cold, yet so Earth-like. There are clouds, winds, seasons, shorelines etched by erosion, channels carved by flowing liquid. But everything is upside down. Where we have rock, Titan has ice. Where we have water, Titan has liquid methane and ethane. Its surface temperature? -179 degrees Celsius. Yet it pulses with chemistry. Cassini's radar pierced the opaque clouds, revealing continents, dunes, mountains made of water, ice, hard as granite, and then seas. Massive, dark, glistening seas. Kraken Mare, Ligeia Mare, bodies of liquid methane, hundreds of kilometers wide. Waves lap at frozen shores. Rain falls. Rivers flow. It's a hydrological cycle, but not of water of carbon. And beneath that alien surface, more secrets. Like Enceladus, Titan may hide an ocean of water below its crust. A double world. Liquid methane above, liquid water below. Life could exist not just in the buried ocean, but even in the methane seas, if it found a way. Cassini and its lander, Huygens, gave us a first glimpse. Huygens parachuted down in 2005, descending through the thick smog, landing on a floodplain, soft as wet sand. It transmitted for just 72 minutes. But in that time, it showed us a world like a dream. And now we plan to return. Dragonfly, a drone-like rotorcraft, will launch in the 2030s. It will fly from site to site, sampling the soil, sniffing the atmosphere, searching for prebiotic chemistry, or more. Titan is not just cold. It is ancient, and it may tell us how life begins, even in the most unlikely of places. Asteroids, the rubble between the worlds. Between Mars and Jupiter stretches a silent graveyard, a belt of broken dreams, of planets that never were. These are the asteroids. Millions of them. Stone and metal, ice and dust. The leftover bricks from the solar system's construction. Too small to become planets. Too restless to be forgotten. Each one tells a story. Some are mere pebbles, spinning silently for billions of years. Others are mountains adrift in space. The largest Ceresus, almost a world itself, rounded by gravity, holding secrets beneath its crust. Others, like Pallas or Hygeia, are jagged, irregular, scarred by ancient collisions. The asteroid belt isn't crowded. It's vast. You could fly through it and never see a single rock, but the threat remains. Now and then, one is nudged, sent drifting inward, toward Earth. We call them near-Earth objects. Some just pass by. Others don't. 65 million years ago, one ended the age of dinosaurs. A silent stone, a cosmic bullet. Today, we watch the skies more carefully. Telescopes sweep the heavens. Satellites track moving shadows. And missions rise. OSIRIS-REx reached Bennu, small spinning top of rubble, and touched it, collected a sample, then turned home. Hayabusa 2 did the same at Ryugu, a dark diamond in the void. We bring back grains of ancient stone to study, to remember. Asteroids are primordial, older than Earth, older than life. Some hold organic molecules, amino acids, the seeds of biology. They may have brought water to Earth. They may have sparked the first cells, but they also remind us of fragility. Not all cosmic encounters are gentle. The DART mission proved we can fight back. We nudged Dimorphos, changing its orbit, a test for the day. We may have no choice. Asteroids are fossils, fragments, warnings. They orbit, unseen, between fire and frost, whispers of what could have been and what might still come. Vesta, Ceres, Pallas titans in the dust. In the asteroid belt's quiet kingdom, some rise above the rest. They are not just rocks. They are relics of ambition, planetary embryos that never reached their destiny. Vesta is first. Bright, bold, a battered goddess with a scarred face. At 525 kilometers wide, she is massive, second only to Ceres. Unlike most asteroids, she has layers, a metallic core, rocky mantle, and crust. She is differentiated, like Earth, like Mars, but her evolution halted. Some call her a protoplanet. Her surface is scorched and cracked, with a crater so vast Sylvia, it exposes her inner layers. A cosmic wound. Meteorites found on Earth head. Meteorites come from Vesta. Pieces of her journeyed through space, fell through our skies. We've touched her only once, with NASA's Dawn spacecraft. It mapped her surface, revealed her ancient history, a frozen story written in craters and grooves. Then there is Ceres, the queen, dwarf planet, water world, mystery. She is round, nearly 950 kilometers across, held in shape by gravity's steady hand. Beneath her dusty crust lies a hidden ocean, a salty brine trapped in rock. On her surface, bright spots gleam. Not ice, but salt deposits in the Alcator crater, left by upwelling fluids. Signs of a restless interior. Could life exist there? In the dark, briny depths, Dawn stayed longer at Ceres. Orbited, watched, it found organic molecules. Hints, nothing more, but enough to wonder. Ceres is quiet, but she watches. A cold ocean world, forgotten between the planets. Pallas is wilder, tumbling, tilted, the third largest asteroid, yet the most mysterious. Highly inclined, she dives above and below the plane of the solar system. We have no close-up view, only glimpses from Hubble and ground-based scopes. She's dark, carbon-rich, possibly watery beneath, but her secrets remain sealed. A visit awaits. Someday, together, Vesta, Ceres, and Pallas are more than relics. They are road not taken. Worlds that started the race but never crossed the finish line. Studying them is like peering into Earth's childhood, into the era before the planets became planets, when everything was still possible, and every orbit carried a dream. Vesta, Ceres, Pallas titans in the dust. In the asteroid belt's quiet kingdom, some rise above the rest. They are not just rocks. They are relics of ambition, planetary embryos that never reached their destiny. Vesta is first. Bright, bold, a battered goddess with a scarred face. At 525 kilometers wide, she is massive, second only to Ceres. Unlike most asteroids, she has layers, a metallic core, rocky mantle, and crust. She is differentiated, like Earth, like Mars, but her evolution halted. Some call her a protoplanet. Her surface is scorched and cracked, with a crater so vast Sylvia, it exposes her inner layers. A cosmic wound. Meteorites found on Earth head. Meteorites come from Vesta. Pieces of her journeyed through space, fell through our skies. We've touched her only once, with NASA's Dawn spacecraft. It mapped her surface, revealed her ancient history, a frozen story written in craters and grooves. Then there is Ceres, the queen, dwarf planet, water world, mystery. She is round nearly 950 kilometers across, held in shape by gravity's steady hand. Beneath her dusty crust lies a hidden ocean, a salty brine trapped in rock. On her surface, bright spots gleam. Not ice, but salt deposits in the Alcator crater, left by upwelling fluids. Signs of a restless interior. Could life exist there? In the dark, briny depths, dawn stayed longer at Ceres. Orbited, watched, it found organic molecules. Hints, nothing more, but enough to wonder. Ceres is quiet, but she watches. A cold ocean world, forgotten between the planets. Pallas is wilder, tumbling, tilted, the third largest asteroid, yet the most mysterious. Highly inclined, she dives above and below the plane of the solar system. We have no close-up view, only glimpses from Hubble and ground-based scopes. She's dark, carbon-rich, possibly watery beneath, but her secrets remain sealed. A visit awaits. Someday, together, Vesta, Ceres, and Pallas are more than relics. They are road not taken. Worlds that started the race but never crossed the finish line. Studying them is like peering into Earth's childhood, into the era before the planets became planets, when everything was still possible, and every orbit carried a dream. Pluto, heart of ice, soul of mystery. For decades, Pluto lingered at the edge of maps. A footnote, a ghost planet, demoted, debated, forgotten. Yet in 2015, it awoke as the New Horizons probe flew past and whispered, "You never knew me at all." Pluto is small, barely 2/3 the width of our moon, yet it holds a world within it. Its heart, Tumba Regio, shaped like a celestial valentine, is not just a frozen plain. It pulses. Slow, ancient glaciers of nitrogen flow across it. Ice mountains 2 miles high rise along its borders, made not of rock, but of water ice-hard as granite in this bitter cold. At its center lies Sputnik Planitia, a vast basin of frozen nitrogen. No craters, no scars. A sign that it reshapes itself still, billions of years after formation. Pluto's atmosphere is thin, ephemeral, a shell of nitrogen, methane, carbon monoxide. It expands as Pluto nears the sun, then collapses into frost as it drifts away. There may be a subsurface ocean buried under kilometers of ice, slumbering in darkness, a secret sea warmed by radioactive decay. If true, it means Pluto isn't dead. It breathes. It changes. It may even harbor the ingredients of life. When New Horizons arrived after nearly a decade of flight, we glimpsed a true world, not a frozen relic. We saw the shadows of towering ice cliffs, the dark patches of Tholin's complex organics formed in cosmic light. We saw haze in its atmosphere, blue as Earth's twilight. Pluto wasn't just icy. It was beautiful, complex, alive in its own alien rhythm. It is no longer the 9th planet, but it may be something grander, a symbol, a frontier, a reminder that wonder lies in the farthest corners of night. Pluto does not need a title. It has a heart, and now we have seen it. Charon and Pluto's frozen kin. In the stillness of the Kuiper Belt, where sunlight is a whisper and the stars burn with untouchable fire, Pluto is not alone. It dances, locked in an eternal waltz with its largest moon, Charon. Charon is no mere satellite. It is half the size of Pluto, so massive that the two don't orbit in the usual way. Instead, they spin around a shared center of gravity that lies in the space between them. This is not a moon and a planet. This is a binary system, twinned worlds held together by gravity and fate. Charon's face is rugged, scarred by time and tectonic violence. A massive canyon system, 4 times deeper than the Grand Canyon, rips across its surface. Its ice plains, smoother than Pluto's, suggest a violent past, an ocean lost beneath freezing crust, a surface reshaped by internal shifts. At the pole, a stain, Mordor Macula, dark red cap, its color born from materials escaping Pluto's atmosphere, and then chemically transformed by solar radiation. They are not just neighbors. They are intertwined. Pluto exhaling, Charon inhaling. Around them drift smaller companions, Styx, Nix, Kerberos, Hydra. Tiny, irregular bodies, some spinning wildly, caught in the gravitational ballet. They are fragments, perhaps born from a collision billions of years ago, when a massive impact may have birthed Charon and blasted debris into the void to slowly coalesce into moons. These minor satellites, spinning like tops, glimmer in reflected sunlight. They remind us that in deep space, even the smallest fragments carry stories. Pluto and Charon, locked in their slow orbit, have always been there. But for most of human history, they were unseen, unknown. Now we know their names, their faces, their scars. We've seen the marks time left upon them, and we know, even at the farthest reaches, there are stories worth telling. The Kuiper Belt and beyond. At the edge of everything, where the light of the sun turns thin and the stars seem closer than home, sprawls a realm of shadows and silence. The Kuiper Belt. It is not empty. Stretching from Neptune's orbit out to 50 AU and beyond, the Kuiper Belt is a vast disk of frozen remnants, the untouched leftovers of solar system formation. Here lie billions of icy bodies, ancient, primitive, unspoiled. They are not just space rubble. They are cosmic time capsules, holding secrets from a time before Earth had oceans. Some are no larger than mountains. Others, like Haumea, Makemake, Eris, rival Pluto in size and complexity. These are the dwarf worlds, orphaned and distant, yet bound to our Sunday in long elliptical orbits that take centuries to complete. The belt hums with slow motion. No roaring engines, no clouds, no wind. Only silence, only motion. Collisions are rare. Temperatures hover just above absolute zero. Time here moves not by minutes, but by millennia. Astronomers once thought it was empty. Now we know better. Thousands of objects have been catalogued. Tens of thousands await. We call them Kuiper Belt objects, or KBOs. Some KBOs show signs of atmospheres or past oceans beneath icy crusts. Others reflect sunlight with crystalline frost, revealing resurfacing events, volcanism, perhaps, but not of lava, of ammonia, methane, ice. Some spin fast, like Haumea, so fast it stretches into an ellipsoid and is encircled by a faint ring of icy debris. Others drift in darkness, undisturbed for eons. Beyond the Kuiper Belt lies something even colder, a shadow of a sphere, a place known only in theory and hope, the Oort cloud. It may extend halfway to the nearest star. We haven't seen it, but its effects reach us in the form of long-period comets, icy messengers flung into the inner solar system by distant gravitational nudges. The Kuiper Belt is our last mapped border. Beyond it, mystery, imagination, the vast. It is a reminder that our solar system does not end at the planets. It blurs, it stretches, it becomes dreamlike. And out there, in the shimmering cold, awaits the next chapter.
you.